Alright, today's lesson in Physical Science 20 comes from 15.3, page 467. And we're going to talk about laws of refraction. We just talked about index of refraction. And if you remember this chart from a previous lesson, each of these indices basically tells us how fast light will travel through each of these. So it's sort of an indication, that's N, it's an indication of how much light slows down when coming from air or a vacuum. So for example, in quartz glass, this number 1.47 is the result over here when you take the speed of light and you divide it by the velocity of light in that medium, so quartz glass. So we're going to talk a little bit more about what N means in terms of angle of incidence and angle of refraction. So these are some laws of refraction. So it says we can predict with accuracy how a light ray bounces off a mirror. We spent a lot of time looking at that. This is thanks to the law of reflection. The angle of incidence equals the angle of reflection. That's something that we've learned before in this course. It turns out that the amount of light, or the amount that light bends when it hits the surface of a new medium, can also be predicted thanks to the careful work of someone named Willebrord Snell. I wish you were named Willebrord Snell. He lived in the 1600s, and he discovered a mathematical relationship that exists between the angle of incidence and the angle of refraction. So we call it Snell's law, and this is Snell's law right here. It involves this index of refraction, and instead of talking about the speed of light, what we're talking about is how this angle, how this index of refraction is built from, or is explained in terms of, an angle of incidence of an incident ray and an angle of refraction, the refracted ray. And so if you look here, this is a diagram. We've seen a diagram similar to this. There would be a certain angle of incidence that this incident ray would make with the normal. And it would bend predictably depending on the kind of substance or the medium that it's traveling into. Snell discovered that if you take the sine, and this is the trigonometric function, the ratio sine, if you take the sine of this angle I, and you divide it by the sine of this angle R, then that also equals the same number as the index of refraction. And so that's kind of good. We don't have to talk about speed of light. We can instead talk about incoming angles of light and how it's refracted. So that's going to help us. Now, a point that I need to make here is that this particular relationship right here holds true when the incident ray is coming out of air. So this is air right here. And it's refracted into another medium. And so it doesn't matter what medium this is. This is just medium number 2. But that's where the N comes from. So which N do you use? You use the N of the medium that the light ray is traveling into. So again, it has to come out of air. So it's in air, then it goes into another medium, and that's the N that you use, the index of refraction for the second medium. So this is in air, and these two are related. The angle of refraction is in the medium that this N refers to. Okay? So that's just a side note. We're going to expand on that in the next lesson, but that's how that works. So again, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant equal to the index of refraction. So that's basically what this formula says. Okay? Sine of I divided by sine of R equals N. And of course, we could rearrange that, couldn't we? We could also say, that the sine of I divided by N equals the sine of R. And so, just like any mathematical formula, we can rearrange that to equal something else. The incident ray, the refracted ray, is important to note that they're on opposite sides of the normal always. So this angle would be on one side of the normal, and the refracted ray would be on the other. That's important. It doesn't go like this. So it doesn't bounce that much. That doesn't make sense. So it's almost straight, but it refracts in just a little bit. Here are some questions that you can do from the textbook that would support this new knowledge here. So again, that's the quick lesson on Snell's law, and it's using the ratio of the sine of the angle of incidence and the sine of the angle of refraction to equal the index of refraction. So we can do a lot of mathematical calculations to find I, R, and to find N even.